and 3. You may start your presentation.
Okay. Hello everyone. We are from Group J. We are presenting about wind energy. Let me close my video first.
Wah,
Okay.
psycho aku je.
I'm Peter Tan Lei Ming, and we have 4 group members: An Chan Yong, Yao Wei Jie, and Muhammad Shamin. So let's go into our slide. Wait. So introduction to wind energy and turbine. So where does the wind come from? So mainly it's from the solar heat power. So first, is due to the uneven heating on Earth's surface. On Earth's surface, there's soil, there's water. So this type of material absorb the sun heat at a different rate. So having a different rate of heat absorption, there's a temperature difference. And temperature difference also cause a pressure difference, and therefore generating a cycle of air current. So the next reason is due to the irregularities on Earth's surface. On Earth, there's a high ground and low ground, mountain, valley. So some higher ground will absorb heat more easily compared to lower ground, as the lower ground sometimes will be blocked by shadow, the shadow of the high ground, mountain, and so on. And this concept is same as the first one, uneven heating. The uneven heating will cause a air current to flow around. So the third reason is due to the Earth rotation. So Earth is like a oval surface, or oval shape. So different part will receive different irradiance from the solar energy. So in Malaysia, we are on the equator, we will absorb more solar heat. And due to the rotation, different part on Earth will absorb heat at different time. So the basic of wind turbine, basically from kinetic energy of the wind, and then will flow to the rotor of the turbine, turn into mechanical energy, also inside the gear, and then transmit into the electrical energy in the generator. So there are basically 2 types of wind turbine: the horizontal axis wind turbine. The horizontal axis wind turbine means that the rotation of the rotor is at the horizontal axis. And the vertical axis wind turbine, the rotation is at the vertical axis. So for wind turbine calculation, this one is just a general calculation. Firstly, we need to find the wind power input. That means the wind power input is energy over time. The energy refers to kinetic energy. And then we can derive into the next equation, half rho A V cube. And then next, we will find the wind turbine efficiency or power coefficient. So this power coefficient actually consists of three parts: the turbine, wind turbine part, the efficiency of the mechanical gearbox, and also the efficiency of the electrical generator. So this efficiency need to consider all the loss inside the wind turbine. And finally, we can find the electrical power or the power output of the wind turbine, where the wind turbine is the power coefficient multiplied by the power input. So here is an illustration of the wind turbine. So next, there are a lot of wind turbine software. So for turbine design software, for example, this one, usually to design the wind blade and also the structural dynamic, pitch yaw actuator, and so on. Based on different software, they actually consider different parts of the wind turbine. So there's a list of the turbine design software. For the flow modeling software, for sometimes the place is hard to measure the wind flow. So they use a prediction of the flow instead in a computer. So it also save more cost in measuring. So here are the list of wind measurement software. There are also many other type of software such as wind farm software to design the wind farm placement and so on. So I'll pass on to my next member.
Okay, Assalamualaikum and good morning. Okay, for my part, my name is Muhammad Syamil bin Muhammad Isa. Okay, for my part is the benefit of applying wind energy. Okay, I show you that they have four benefits for applying wind energy. Actually, they have more, but I show that four benefit that close to us. Okay, first about wind power is cost effective. Okay, it has the lowest price energy source. It costing about 1 to 2 cents per kilowatt hour. So it doesn't matter whether the cost is 1 or 2 cents because the price is still the lowest. Second point is about the job opportunity. Okay, this is based on the Wind Vision report. It states that it has the potential to support more than 600,000 jobs when install the wind energy. It include in the cost manufacturing, installation, maintenance, and supporting service. Okay, for the third point is about clean fuel source. Okay, it doesn't pollute the air like power plant because it doesn't need the combustion process. Okay, so it don't produce atmospheric emission that cause acid rain or smoke because we just use the wind energy. It doesn't need the combustion, so it doesn't have smoke. Okay, next point is about the sustainable. Okay, as the wind blow, the energy produced can be harnessed to send power across the grid. Okay, this four is the benefit of applying wind energy. Is the benefit easy to we understand. Okay, next slide with Okay, for the next topic is about the potential usage wind energy in Malaysia. Okay, based on the government, it has been discussed that it should install it on the onshore. So they propose to build wind turbine in the sea on the east coast of Malaysia. However, Renewable Energy Act 2011 it state that biogas, biomass, small hydropower and solar PV is included in the renewable resources but not include with wind energy. So that's uh, will be hard for the government because they think that wind energy is difficult to get the source. Okay, second point is about the development. Okay, to install the wind energy in Malaysia, it's supposed minimum wind speed about 4 meter per second for electricity generation. However, in Malaysia, the wind speed is more than meter per second, so it will be hard. So, however, Kuala Terengganu, Mersing and Kudat has shown that they that place has the potential to install the wind energy. But wind speed is not constant because due to monsoon. So that means the wind energy will be achieved 4 meter per second or above if the it's come to the monsoon. Okay. For the third point is about study. Okay, wind turbine in Malaysia have been installed for educational only. So that means it uh it, it doesn't state that it cannot use for generate electricity, but it's need the biggest the bigger I can say that the bigger wind energy to generate electricity for the Malaysia. So some university use it just for the study for the student. Okay, next slide. Okay. This is some example of wind turbine installed in Malaysia. Okay, they have four types. Okay, first about 50 kilowatt of wind turbine at Pulau Terumbu Land Sabah. Okay, it has been installed by TNB in 1995. So that place show the greatest wind energy potential. Okay, the second it more to the combination. It has 100 kilowatt of wind turbine with the 100 kilowatt solar PV and 100 kilowatt at Perhentian Island Terengganu. However, the wind energy to be not successfully generated because the turbine have stopped working due to some issue. So but the issue doesn't have state whether or internet or something. It just state that they have some issue why the turbine have stopped working. Okay, next about 3 kilowatt to 25 kilowatt of wind turbine at Kudat, Kuching, Kuala Perlis and Terengganu. Okay, the result of the project also never be published, but uh, it already state that it had been installed. But what the result or whether it's successfully or not, it never be published. Okay, then for the fourth one is about 3 kilowatt of wind turbine in Situ Terengganu. Okay, this part of project is handled by UMT. So it used to supply electricity to help shrimp farm industry in reducing the high operation cost. However, whether it's successful or not, it based on because the UMT doesn't have show us the result, so it cannot be stated that whether it has been successfully or not. But UMT has show that it had study to install the wind energy to help the shrimp farm. That's all for me.
So now I would like to present about the barrier and challenges for the implementation of wind turbine in Malaysia. There are some barriers or even challenge for the implementation of wind turbine, which include the market failure, market distortion, economic and financial, institution, technical, social, and others such as the unsupportive of government policies. This challenge mostly concern about the investment and capital costs and even the lack of technical skill and knowledge for wind turbine. Next. Next, I would like to present about the optimal generation cost-based tariff. And this research is obtained from an article, namely the optimal generation cost-based tariff rate for onshore wind energy in Malaysia. The aim for this economic feasible analysis is to calculate the optimal level of tariff, which is suitable for wind local condition. And by referring to, and as you can see in the table, this table indicates the impact of investment cost on the feed-in tariff rate for wind energy in Malaysia. By referring to the assumed capital expenditures, which is the small scale wind turbine that had 12,500 kilowatt hours and the utility scale wind turbine 10,000 per kilowatt hours. The sensitivity analysis were up to plus minus 30%, and the 30% is utilized as it will generate the initial investment cost in within the range of investment costs reported for wind energy project globally, which is in Asia and even in Malaysia neighboring country. This shows that the baseline feed-in tariff increased in accordance with the increment of investment costs Thus, the baseline feed-in tariff is expected to decrease annually due to the annual dispersion of wind turbine costs. Next will be a case study obtained from the same article just I mentioned before. The case study was set in the site located at Kudat, Sabah, namely Babak. From the research, Kudat is a well-known region that has promising wind potential in Malaysia. And during this study, 10 models of wind turbine were introduced, and two models has been selected, which is the small-scale wind turbine Demos and utility-scale wind turbine Suzlon. The table above shows the result of economic metric analysis for optimal number of two models of wind turbine that are placed on a 1 kilometer area of a selected site. As you can see from the table, the A is K A is the closed form equation that includes the capital allowance, and B is the closed form equation that excludes the capital allowance. From the table, the discounted payback period will be defined by discounting the annual cash flow and considering the time value of money. But the simple payback period is not. This explains the reason why the value of discounted payback period is lower than simple payback period. And also, the availability of capital allowance will increase the revenue in the early year of period. But when the capital allowance is excluded in the cash flow, there is no additional revenue in the early years, and it will lengthen the discounted payback period. And that's all for me. And I would like to pass it to Liu Weijie to continue the speech.
My name is Riwajan. Now I will talk about the Malaysia Wind Power Agency. Sustainable Energy Development Authority, which is SEDA, Malaysia, is the agency who is responsible for the development of the regulatory framework for wind energy in Malaysia. It is formed under the Sustainable Energy Development Authority of 2011. The role of SEDA is to administer and manage the implementation of the feed-in tariff system. SEDA is committed to operate with all of the functions conferred under the Renewable Energy Act 2011, which is an act that provide for the establishment and implementation of a specific tariff system to catalyze the generation of renewable energy and to provide for related matters. Slide. SEDA logo has hidden meanings. For example, for the circle, it represents the sun, which is the largest source of renewable energy. And the circle can also be considered as the Earth, remind that the sustainable use of energy impact the entire planet. The circle has no end, which means is the unending effort of SEDA. And for the leaf, it represents the source of renewable energy includes organic plants. And being organic to grow in wisdom and in strength with time. The silver color in the SEDA logo is one to remind that its reputation depends on efforts of members to shine or tarnish, just like silver. Malaysia can be an example to promote development of sustainable energy in country if carrying out with care. If not, it will tarnish country's image. For the blue color, it represents the water, which is another source of renewable energy. It denotes creativity, trust, loyalty, and authority. Next slide. Now I will talk about the financial support for wind energy. For now, The Green Technology Finance Scheme 2.0 is the only finance scheme provide for wind energy. It's a finance scheme offered to investors which is supported by the government, offering a 2% PA interest rate subsidy for the first 7 years and 16% government guarantee of green component cost to financial institution. The site have shown that the 55% of the balance of GT for finance and another 45% is the proof GT for finance. And another chart is show the GTS project financed by the banks in Malaysia. And I will pass to my group member for the next slide.
So in conclusion, the wind energy can be domestic source of electrical energy in Malaysia, but it can only be applied in limited area and specified period. The wind energy does not fall within the category of renewable energy under Renewable Energy Act 2011, which is the IEA. And however, Energy Commission Act 2011, ECA consider the wind energy to be one of the resource renewable energy. And also, the demand for other resources such as solar energy was drastically higher than wind energy, as we are in the equilibrium or in the center or equilibrium at the Earth. Even though the investment cost for the solar panel is higher than the wind turbine. And that's all for our group. Thank you for listening.